Hi everyone. We're going to discuss a new chapter, and this is all about solving simultaneous linear equations. And the first one that we're going to have is solving simultaneous linear equation by graphing. So if you are watching this, I would like you guys to bring your graphing paper so that you will easily know how to graph certain equations. Okay, so as you can see here, I already put the steps. And the first step that we're going to do for us to be able to graph and solve these equations is to make tables for both equations. So let's say that we're going to have two tables for these equations. So let's say this is the table exclusive for 3x minus y is equivalent to 0. And then the next one will be for the table of 2x minus y is equivalent to 1. Now, the next thing that you're going to do is to make four columns and 2 rows. So it was done there. So the same thing is what you guys are going to apply for the next one. And on the first column, you are going to put the values or the variables x and y. Okay. So from here, you will now, what you're going to do is you are going to reformat this particular equation. So we can say that these 3x minus y is equivalent to 0 can be rewrite as y is equivalent to 3x. Okay. Which means that for you to be able to find the coordinates, what you need to do is to substitute of particular values for the x so that we can have a certain values for the y, a certain value for the y. So let's say, for example, I have here 3x and I want the value of the x to be 0. So this will give us now a calculation of y is equivalent to 3 times the value 0, which is going to give us an answer of 0. Okay. The next one that we're going to do is to think of another number. So let's say I want number 1 to be the value of the x. So in here, you are now going to substitute that one the same way to how we substitute 0. So it's going to be 3 times 1. And this is going to give us an answer of 3. So that means the y is equivalent to 3. Okay. And then you're going to continue. But however, you have to pay attention that at the bigger value you put for the x, the bigger value for the y that you're going to have, which means that it would be harder for you to graph it, or it will take much of your time just to put in these points. So what I'm going to do here is I'm going to make it a bit smaller. So this time, I'm going to go back to the negative value. So let's say if I put negative 1 as the value of the x, then this would give me a calculation of y times 3. Y is equivalent to 3 times 1. So this is going to give me negative 3, which is way more convenient to graph. Okay. So the same procedure is what you guys are going to apply for this particular equation. So let's say, for example, we're going to have this rewritten as y is equivalent to 2x minus 1. And we say that if I'm going to substitute the value of the y as equivalent to 0, so this is going to be a calculation of 2 times 0 minus 1. So 2 times 0 is 0. So this is going to give us negative 1. So that means if the value of the x is at 0, then that means the y is equivalent to negative 1. Okay. So you will just continue the process. So let's say I have 1 as a value for the x. So I will write here 1 and substitute. You can now have this as 2 minus 1. wherein the y is equivalent to 1. Okay, so if the x is 1, then the value of the y is 1. So another one is for, let's say I want to put it as 2. So that means 2 times 2 minus 1 is going to give me 3. I'll just put it here, yeah? So y is equivalent to 2 times 2 minus 1 is going to give me 3 minus 1. 4 minus 1. So that means your y is equivalent to 3. So that means the point that you're going to have now is 2, 3. All right, so now some of you might be asking, what is the importance of having these tables? Okay, or these these values that we have? Well, actually, these values that you have for the x and y will now serve as the coordinates of your points. So let's say, for example, this is 0, 0. This is 1, 3. And this is negative 1, negative 3. And this one is 0, negative 1. This is 1, 1. And this one is 2, 3. All right. So you now have 3 points that you could graph. You can graph in your graphing paper, but we have to be specific that it states here that the scale of the graph should be 1 centimeter is equivalent to 2 units for the values of x and y. All right, so it says make x and y axis following the scale given. So as you can see here, this is not the one that is in the scale. So what you need to do is you have to make sure that the scale, okay, is going to be particular with this scaling value. So that means 1 centimeter is equivalent to 2 units for the x, and 1 centimeter is equivalent now to 2 units of the y. Now, as soon as you get these x and y axis, what you need to do now is to plot these points. So let's say the points for the first equations are 0, 0, 1, 3, and negative 1, 3. So I will just plot these points, 0, 0, 1, 3, 1, 3, and the next one is at negative 1, negative 3. So negative 1, negative 3. And what you need to do next is to connect these points and extend the line that you're going to have. So let's say this equation is equivalent to 3x minus y is equivalent to 0. So I will just have 3x minus y is equivalent to 0. And this is the point that you guys plotted and extended, connect them to make a line. Now, the same procedure is what you're going to apply for the second equation. So again, these points are going to be plotted to that particular graph. So we have 0, negative 1. So I will just write here 0, negative 1. The next one is at 1, 1, if I'm not mistaken. So 1, 1. And 2, 3. Okay. So these are the points that you acquire coming from those. And what you need to do now is to extend these lines for you, extend these points to make a line. So this is 2x minus y is equivalent to 1. Okay, so 2x minus y is equivalent to 1 minus y is equivalent to 1. And you will see that these two lines intersect at a certain point. So you will see here that this point is the point that intersected these two lines, or this is where the location, this is the location where these 2 points intersected. So that means this point is going to be the solution. All right. So if we are going to write here the solution, so that means you are going to have it as let me just have it here. Solution is that x is equivalent to, let's see, x is equivalent to -1. So we write here -1. And the y here is equivalent to -3. Okay. And this is how you are going to graph or solve these equations using graphing. So the intersection will give us the solution for these two equations. Now, what I want you to do is to pause this video and try to answer this particular equation. Okay, you may start. All right, let's suppose that you guys were able to uh, get these tables, substitute the values of the x for you to get the y using these equations. And this time we are going to see the equation of these points or these lines. So let's have it again. So the first equation that we have is 2x, x minus y is equivalent to 3. So I will just write here x minus y is equivalent to 3. The next one is at x minus 2y is equivalent to -1. So x minus 2y is equivalent to -1. All right. So you will see now that there is this point of intersection for these two equations of a line. And as you can see, there is a particular x and y coordinates that they met. Okay, and that would mean that the solution for those two particular equations are said to be 7 and 4. 7 for the x and 4 for the y. Okay, I hope you guys were able to understand that. Now, we're going to move on to this next question. Now, as you can see here, for this question, it does not provide any single unit for the variables x and y. So in this case, there's nothing to worry because the procedure will automatically just be the same. Okay. First is you're going to make a table. Put these particular values. xy, xy, and then this one is 2x minus 5y is equivalent to 32. Okay, and then the other one is 2x plus 3y is equivalent to 0. Okay, so let's go for the first equation. Now, as you can see, in this particular part, we have to think of what value you are going to substitute so that the final answer could give us an exact number. So remember, fractions are hard to graph, and so as decimals, particularly fractions that are said to be repeating fractions, okay, or the one that is non-terminating, okay? So we have to put a certain value here that could give us an exact value for the first equation. So let's say, for example, if I'm going to do this, I'm going to rewrite this as 5y is equivalent to 2x minus 32. Okay, so I'm going to think of a value for the x that I have to substitute so that when I calculate this, the answer can be divided by 5. Okay, so let's say, for example, I should get a value of 30. Is it possible for me to get a value of 30? Yes. So if I put 1 here, then automatically this will give me a calculation of 2 times 1 minus 32, which is equivalent to 5y. And this will give us 5y is equivalent to negative 30, which is going to give us an exact value for the y. So here, the y now is said to be equivalent to 6, negative 6, I mean. Negative 6. Okay, so if that is 1, then this is going to give us negative 6. So again, you're going to think 32 become 30. So is it possible for you to make it 22? Yes. So how do you make it negative 22? So we are going to provide a value of 6, so that negative 32 minus 12 is going to give us a negative 32 added by 12 is going to give us 20. So this is going to be minus 20. So this is going to give us 5x, 5y is equivalent to 2 times 6 minus 32. So this is going to give us 12 minus 32, which is 5y is equivalent to 20, negative 20 particularly. And then y now is going to give us a value of negative 4. So as you notice, guys, I'm always being particular with whole numbers so that when I graph it, it will be easier for me to graph, and the answers or the connections will be as good as I want it to be. All right, the next thing that you're going to do is to make this closer to 30 is 32 is 40. So you have to manipulate. What should I substitute to this equation? So I will get a value of negative 40. So you know that if I substitute negative 4, this is going to be the calculation. So this is going to be negative 40, which is equivalent to 5y. So y now is going to be equivalent to negative 8. So notice here, guys, that Mr. Ronald is manipulating the values so that it will be possible for you to have an exact number, exact values for x and y, and at the same time, the numbers are not that big, which means that it will be more time efficient for you to graph these lines. Okay, the same thing is what you're going to apply here. So let's say we have 2x minus 3y, so we can say that 3y is equivalent to negative 2x. All right, so you're going to think, what should I substitute to the x so that the answer can be divisible by 3? So I want to, let's say I want to make it negative 6. So I will substitute 3 here. So if I substitute 3, this is going to give me a calculation of 3y is equivalent to negative 2 times 3. So this is going to be y is equivalent to negative 2. So negative 3 times 2 is 6 divided by negative 6 divided by 3 is negative 2. So you will now have the first point of your line. And then the next one is, again, you just continue. So let's say if I have negative 2 here, then if I put negative 3 here, then why do I put negative 3 as well? So let's say if x is negative 3, then this is going to be a calculation of 3. Y is equivalent to a negative 2 times negative 3. So this is going to be y is equivalent to 6 over 3, which is equivalent to 2. right? So notice that if you put an opposite value, automatically the answer will also become its opposite. And the easiest one, the most easiest one, and the easiest one is we put it as a 0. So if you put the x as a 0, then automatically the y will become 0. So now, as soon as you get these points, automatically you are going to put it in the graph. But again, check the scale that has been given to you. So it says here the scale is 1 centimeter is equivalent to 1 unit of x. So now you're going to make your graphing paper, okay, and arrange it in such a way that you will be having a scale of 1 centimeter for the value of x and 1 centimeter for the value of the y. So this is what you guys are going to have now. So the same procedure, we plot these points. So let's say you already know that these are the points. So we have 1 and -6. 1 comma -6. The next one is 6 comma -4. The next one is -4 comma -8. Okay. So wait a minute, why is it not there? Okay, so it's at, apparently it's at the bottom. So this is what you guys are going to have. So let's write down the equation. 2x minus 5y is equivalent to 32. 2x minus 5y is equivalent to 32. Okay, so that is now the line that you guys have. And then we're going to continue with the next one. So the first point is at 3, comma -2. So we write here 3, comma -2. The next one is 3, -3, comma 2. So -3, comma 2. And then the next one is at 0, comma 0. So 0, comma 0. And as you can see, all right, these are the 3 points that you can have. And if you extend the line, it will intersect to the other equation. So let's just have the equation as 2x plus 3y is equivalent to 0. 2x plus 3y is equivalent to 0. So this is going to be the intersection of the lines, the equations that you have. And according here, the intersection is 6, comma -4, which would mean that the solution of these two equations, okay, let me just write it here. Solution is that x is equivalent to, let's see it again, 6, and y is at -4. So once again, the intersection of these lines are said to be the solution of the two given equations. All right. I hope you guys fully understand the discussion. And I hope you learned something here. This time, I want you to try this one, guys. All you need to do is to pause this video and start doing this. And once you get the answer, then you may continue watching the video to see whether you get the correct answer. Okay, pause this video now and start. All right, let's say that you guys already did it. Okay, so we're going to plot these equations that we have. And as we know, it has the similar scale to what we have, so you will not have a hard time. So we will now be having x plus 4y is equivalent to 12. So I'll just put here x plus 4y is equivalent to 12. And the other one is going to be equivalent to 4x plus y is equivalent to 18. 4x plus y is equivalent to 18. All right, so from here, you will see the intersection. And it says here that the intersection is at 4, 2, meaning to say the solution is x is equivalent to 4 and y is equivalent to 2. All right, that's it for this particular part. By the next video, we are going to discuss solving simultaneous linear equation by elimination. Okay, that's it for now. Have a nice day and ciao.